All right, we are starting the session for today.
Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Introduction to No SQL Databases for Big Data. Our guest speaker today is S. Mohan Kumar. He is the co-founder and CEO of Trendwise Analytics. Mohan Kumar is the co-founder and CEO of Trendwise Analytics. He has more than 23 years of rich IT industry experience, working for global companies like SAP and IBM in a variety of leadership roles. Prior to forming Trendwise, Mohan was with IBM for about 5 years and SAP for 11 years, including a short stint of 4 years in the US. As Vice President CRM at SAP Labs, he built the CRM development team from ground up. Mohan is a graduate from IIT Kharagpur. So, without further delay, I introduce you all to our guest speaker. Over to you, Mohan.
Thank you, Aradhana. Hello, everyone. I would like to extend a warm welcome to this session. This topic is about NoSQL in the context of big data. And what we're going to do is this will be about 45 minutes of presentation, followed by 10 to 15 minutes of Q&A session. And I think you can put your questions in the question panel that is available to you. And then at the end of the session, we will take it up. So the agenda for today is basically to provide a quick overview about NoSQL, and it is primarily targeted at people who are new to NoSQL and also to big data. While the session will not make you an expert on this topic, what I can promise you is that you will get enough ammunition to have an intelligent conversation with your colleagues and friends on the topic of NoSQL and database and big data. And also, you will get familiarized with some of the jargon that is thrown around when we talk of big data and NoSQL. So that is what we will do. And so NoSQL without the context of big data usually it's very difficult. So I will start off by introducing the topic of big data, and then we will go into NoSQL in a little more detail. All right, so what is big data? Some of you must have already heard about this, and before I talk a little bit more on this slide, what I would also do is I would like to bring your attention to the URL at the bottom of this slide. So if you have a browser around, you can put in this URL. I'll come to that in a bit. So what is big data? When we talk about big data, the 3 V's come into play. This is somewhat cliched, but still I think this is one of the best ways to explain big data. The first thing is about the volume, the amount of data that is getting generated on a daily basis. We are all aware of this. There is no need of much of explanation. But what is different is that traditionally when we talked about data, what comes to our mind is a table, which is a bunch of rows and columns. And that's how typically enterprise data was stored and is still stored. But now when we talk of data, it is not just the enterprise data, but it is all kinds of data that everyone is generating. People like you and me, we have social media accounts, Facebook accounts, Twitter accounts. So we generate a lot of information. All this now comes under data and big data. And this is the variety part of it, the second V. So the variety refers to what is known as the unstructured data, which is all the text that we generate, all the audio files, all the video files, all that comes under variety. And according to one study, 80% of the new data that is generated is unstructured data in the form of text, audio, and video files. So that is the second V. And the third V is velocity. Velocity has two components. One is, of course, the rate of change of information or data, and also the concept that using the data at the right time. So if the data is generated and we don't take action at the right time, that becomes obsolete. Let's take a very simple example of a credit card fraud. When a person swipes a card, and if it is a fraudulent transaction, as soon as the card is swiped, actually data is generated, but unless we are able to detect it immediately, it's probably too late. That is the velocity aspect of it in a very simplified way. Now, this URL, if you see, that basically you must be seeing there, animated version of how data is generated, how fast, the rate at which data is generated, amount of data that is generated, and so on. So that's an interesting way in which MapR has kind of tried to depict the rate of change of data and the amount of data that is being generated. I hope you were able to see it. I didn't want to switch in it so that we don't get disrupted, the session doesn't get disrupted. So the rate or the volume of the data that, the rate at which the data is increasing is phenomenal. So this slide basically shows that. You can, you will see that the units that we are using is no longer even terabytes. We are talking about exabytes. So by this slide shows how the data will grow for the next 5-6 years. So 2020 is what we are showing here. So you can see that the rate of growth is actually exponential. So that is the whole issue of big data. So how do we solve this problem? How do we handle and manage this large amount of data, structured and unstructured? So the technology to handle this, one of the technologies I would say, is Hadoop. Hadoop is a big data platform. Doug Cutting is considered to be the father of Hadoop. He was a former Yahoo employee. And as you can imagine, companies like Yahoo and Google were the ones faced with this problem of big data. So that's where it started. I'll not go into a lot of details of Hadoop. So basically it is a platform, technology platform to handle big data. What it does is it provides a facility to divide and conquer. So basically provides help with distributed computing. So if you have a terabyte of data, all it says is connect 100 computers, distribute the data, process it, and analyze it. Some of you may be thinking, well, distributed computing is nothing new. So what's new about this? I think what's new is that Hadoop works on commodity hardware. So you can install Hadoop on your laptop. Unlike earlier versions of distributed computing like mainframes that needed really powerful hardware. Another good thing also is that Hadoop is open source. And you will see that mostly in big data, a lot of the software is open source. That's the good part of it, or the best part of it. Now, Hadoop also provides a bunch of other components. I hope you're able to see the slide saying Hadoop components. Just give one moment for the slide to come up. Okay. So it provides a bunch of other tools to handle big data. For example, it provides something called Scoop, which is like ETL, which is used for importing data from a regular SQL database, or RDBMS, not SQL, but RDBMS database. It provides a programming framework called MapReduce, and it provides a database, NoSQL database called HBase. So that's the first entry into NoSQL. So HBase comes with Hadoop, but all other NoSQL databases can work independently and need not be always used along with Hadoop. This is usually a myth some people have, so I just thought I'll clarify. So that's a quick intro about Hadoop. So let's go into NoSQL databases now. So what is NoSQL? I would like to start by saying that this is one of the biggest misnomers in the IT industry. NoSQL doesn't mean we don't use SQL at all. All it means is that it's a flexible database which doesn't need a rigid schema. So it's more a no schema or schema-less database. So that is a very brief definition, if you will, of NoSQL, but actually there is, it's a little difficult to really define that. Now, all we can say is that the reason for NoSQL is big data. That is the reason I thought of starting off with big data. And in this slide, you will see that according to one of the surveys, companies were asked why people were moving towards NoSQL. I think one of the biggest problems was the lack of flexibility or the requirement of rigid schemas in case of traditional databases or RDBMS. The second problem, of course, was scale, the inability to scale out. So when the data grows drastically, scaling out is a big problem. And of course, third is the performance. So these are the three main causes for the introduction of NoSQL. So what are the advantages of NoSQL databases compared to a traditional RDBMS? The most important one is that it has a flexible schema. Schema-less, again, is a little controversial because there is actually an implicit schema, but what it means is that you don't have to start off with a schema. So traditionally in RDBMS, when you want to do a database design, you come up with the design of the tables and then the schema of the tables before you do anything else. So in case of NoSQL, that is not needed. I would also like to bring in a little bit of caution here that some of these concepts may be a little drastic in terms of paradigm shift, especially for those who are used to RDBMSs. So don't worry, it will need a little bit of reinforcement. So if you're not able to grasp everything, that should be fine. The second aspect, of course, is these NoSQL databases are highly scalable. Now, horizontal scalability is another jargon you will keep hearing. What it means is that typically when you feel your server is the size is not enough, one option for you is to increase the size of that server by putting in more memory or increasing the disk space or putting a more powerful CPU maybe. So that is typically referred to as vertical scalability. Horizontal scalability is the ability to add more machines. So that is all what is about horizontal scalability. So you can create a cluster of maybe 10 machines, so you get more scale and more power. And last but not least, as I mentioned, most of the NoSQL databases are open source, so pretty much free. So where do you use NoSQL databases, and why do we not use NoSQL databases everywhere? I think there are certain areas where NoSQL databases make a lot more sense. They are, again, not a solution to all problems, and certain areas where probably they will not be suitable. So NoSQL databases are suitable where there is continuous data coming in and it's in large volumes. For example, sensor data or Twitter data, log data, things like that. These are typical use cases where you use NoSQL databases. On the other hand, if you have some application which is very transactional, like for example, you need to create orders, you need to create customer details, and they're all linked to each other. Order is related to customer, and then order line items is related to order header, and so on. So RDBMS definitely is the best choice there. So what are the various types of NoSQL databases? Now there are a variety of NoSQL databases, and very often we will see that each one is quite different from the other. So it's sometimes very difficult to even bundle all of them together as NoSQL databases. But by and large, they have been categorized into 4 groups: the key value store, the column store, document databases, and graph databases. And key value store are further subdivided into persistent and volatile. You must have heard of in-memory. So volatile refers to the in-memory databases. So these are the 4 broad categories. Now we will go into a little bit more details of each of these categories. So quickly, a few examples of each of these, and I think we will cover some of these in a little bit more detail. So key value store examples of this type of NoSQL databases are RIAK and Redis. And column family, probably the most common ones are HBase and Cassandra. And Datastax is a commercial version of Cassandra. And document databases, the most common or popular ones, in my opinion again, are MongoDB and CouchDB. And this is not a complete list. This is by no means a complete list, just for examples. And graph databases, probably the most popular one is Neo4j. And we will talk about it in a little bit more detail. So key value stores are based on Amazon's Dynamo, or Dynamo database. And as the name suggests, it has a very simple data model. There is a key and a value. And when you're storing the information, you generate the key and store the value. The value can be anything. You can store any information. And this is, again, highly scalable and very fault tolerant, which means that there is redundancy. So if it is in a cluster, and if 1 or 2 nodes go down, you don't lose the data. There is redundancy. So we will take RIAK as an example of this type of database and take a look in a little bit more detail. I hope you're able to see the slide now. So the way data is stored here is that primarily two levels. Okay, we'll come to the data model very quickly. A few points about RIAK. It is, again, a distributed database. And the good point is that it doesn't have a central coordinator, which means that there is no single point of failure. And it is highly, again, horizontally scalable and fault tolerant. So already mentioned about this. Now let's take a look at how the data is organized. So the data is organized in the form of buckets, which is at the top level. And then you have the key, which is a binary blob to identify each of the values. And then you have the values, which are any and every possible data type. So this is as simple as that, just a key and the value. So you need to know which bucket, which key, and then you can fetch the value. And how does it work? A few sample code and a few commands are shown here. It's very simple. Once you install RIAK, all you need to do is run this command RIAK start. And then if you want to start another node, you just go to the second node and do the same, RIAK start. And then if you want to combine these two into a cluster, you just have to run the command RIAK admin join and RIAK at the rate of that IP address. And you do this for each of the nodes, and that's how a cluster is set up. So it's very easy and simple to use in that sense. And programmatically, you basically use HTTP APIs. So from your program, you can access the data. There are APIs available. So this is, let's say, a difference with respect to RDBMS. You don't just do queries, but you are provided with APIs in order to access and manage the data. So here are a few API commands. So if you want to store the data, you have the post API. And if you use it without the key, RIAK will define the key for you. And if you use put with the key, you need to define the key and provide it. So that's how you create the records, you create the data. And in order to fetch the data, you use the API get, and you mention which bucket and which key, and you will get the information. And then if you want to delete, you need to just use delete, mention which bucket and which key, and that particular record gets deleted. So these are some of the commands and APIs. So just to give you a flavor how it looks. Next we go to column family. So column family is based on Google's Big Table. And here again, the data model is pretty simple. It's somewhat like traditional databases. Only thing is that instead of storing in the form of rows, the information is stored in the form of columns. That is the basic change here. And again, there are APIs provided for querying and processing this information, this data. And some of the common examples of column family are HBase and Cassandra. Cassandra is very popular. So let's take a look at how the data is stored and what are some of the commands and a sample code. So Cassandra provides, Cassandra, we are taking Cassandra as an example of a column database, and pretty much other column databases will be in a similar way. Now Cassandra provides what is known as SQL or Cassandra query language. So once you install Cassandra from the terminal, from the DOS prompt as we call it, you can go to CQLSH shell, and in order to create a key space, you use the command create key space, give the name, and there are certain parameters about the replication you need to provide. So that creates the key space, and then you use that key space to create your tables and column families and so on. So in order to create a column family, you go to that particular key space. In this case, let's say my key space, and you say create table, the name of the table, and then you provide the columns that you want to add. So basically this is known as a column family. We normally don't refer to it as a table. So you create a column family with the required columns, and that's how you create a column family in Cassandra. Then there are a few more in the next slide. Just give a moment for the slide to appear. So as you can see, if you want to see what are the various tables that are available in this namespace or the various column families, as it is referred to in case of column database, you just simply write the command describe tables. And if you want to see what is the implicit schema for a particular table, let's say user in this case, you type describe table and that particular table name. Now you see that this looks very familiar. It is pretty much SQL commands, right? Similarly, if you want to insert records, you pretty much use the command like in SQL. So you say insert into, and then the column family name and the values that you want to insert. And then if you want to fetch the records, again, this is very familiar, especially for all the RDBMS folks. Select star from and the table that you want. As simple as that. And similar commands are there for update and delete. So as I said earlier, it doesn't mean we don't use SQL at all. So we do, in some instances, we do use. Okay. So what else? Next is document databases. And here again, the data model is in the form of, at the top level, you have databases, then you have collections, and then you have fields. The collections are the equivalent of tables in traditional database, in traditional RDBMS. And the fields are basically the values that we store, and this is stored in JSON format. Many of you may be familiar. JavaScript object notation, or binary JSON, or BSON as we call it here. And the most common examples of document databases are CouchDB and MongoDB. One of the common usages of this is analyzing maybe blog posts. So unstructured data you take and then analyze it. The next slide, wait for it to refresh. Basically, some sample code again. So you have, let's say, in this case, we are taking MongoDB. So let's say you installed MongoDB and you want to start creating tables and records and so on. So one way of creating a table is to do it explicitly, but typically, in case of MongoDB, a table gets created when you do a first insertion. So here we have an example. Sorry for that. So here we have an example. Just checking if you can see the slides.
Mohan, I think there's a problem with your network. You just got disconnected. So can you please log in again?
Let me just check.
Your audio is very much there. It's
Okay.
just that, yeah, you have logged out.
Okay, let me just check that. Session shows as I'm in, so shall I close and relog in?
Yes, please re-log in. You don't need to disconnect from the call. You can just re-log in because the audience is able to hear you.
Right.
They cannot see the screen.
Okay. All right, yeah, let me just restart the webinar session.
I request all the audience to be online. Mr. Kumar would be back online very soon.
Yes. Yeah, should be there in a minute. Yes, I think I'm back on.
Hello, Mohan. Can you hear me?
Yes, Yes, I can hear you, and can you see my slides?
Yes. Your slide is very much
Sorry about
visible.
that.
It's sample code commands. You can continue with the
Yes,
presentation.
thank you very much. Hello everyone, sorry for the interruption. So we are on the MongoDB sample code. So what this slide shows is basically a couple of lines of sample code. If you want to insert or create the table in a column database like a MongoDB, there are two ways. One is you can explicitly create it. At the bottom, there is a create collection or create collect. And you give the name of the database, users in this case. Or it can happen automatically when you're inserting your first record or document. That's what's shown on the upper side of it. So that's how we create a collection family in MongoDB. There are other commands or APIs, which is basically to query the data. So for example, fetch will fetch all the records. This is equivalent of select star in traditional databases. And then of course you have update if you want to update a particular record. You get the update with the particular record that you want to update and the values with which you want to update. So this is sample code for updation. Then we have graph databases, which are basically used or very helpful, very powerful when we are creating something like a social media application. And this is also based on graph theory. And here the data model is quite different from others. There are nodes, which basically are the primary objects, if you will, and then you have edges and properties. And we are all familiar with these kind of graphs, like we have in, for example, Facebook or LinkedIn and so on. We have a person and he has several friends, and then he has a network of friends and so on. So that's the kind of applications where this is extremely useful. And Neo4j and Infinite Graph are some of the common graph databases. And what we'll do is we'll take a look at Neo4j in a little bit more detail. In general, in a graph database, it is very whiteboard friendly in the sense that building the schema or something like that is not very difficult. That's why it's called whiteboard friendly. So if you have a problem description, the nouns in that become the nodes. So for example, people can be the nodes, and the verbs are relationships, and properties are the adjectives and adverbs. So that's why it is called very whiteboard friendly. Let's take a little bit detailed look at Neo4j. So it is a Java-based NoSQL database. It has massive scalability, of course. And I think the best part is the traversal. We can also create a network database using probably an RDBMS, but if you want to traverse it, I think it's extremely painful, and we will see some examples of that as well. And like all other NoSQL databases, this is open source, and the language that is used for manipulating or managing data in Neo4j is called Cypher. It's a declarative graph query language. And we'll see some, again, sample code and commands here as well. So this is a sample code for creating a graph. Again, this is by no means complete, just probably I should call it as a code snippet. So in order to create a new graph DB, you create a new object, and then you keep adding to that, keep adding nodes. So in this case, for example, you're creating a new node, Mr. Watson, and then you use the methods like set property. So the name of, you're setting the name of the node Mr. Watson as Tom Watson, and then you're setting the value of the age as 29. And similarly, you create one more node, in this case, let's say Sachin, then the name is Sachin Tendulkar, and then you establish a relationship between them called friendship. And it's, again, the commands are pretty straightforward and very much English-like. So that's how you create a simple graph, maybe of two people, and establish their relationships. Now, how do we traverse the particular graph? I think that's the best part of a graph database. Let's say you want to get all the friends of a particular person up to level 5. In case of a regular or traditional RDBMS, it would have been extremely difficult. While it is not impossible, it would have been very difficult, extremely difficult. But in this case, as you can see, it might look like a very lengthy code, but it is just one line of code, and that will fetch all the friends of a particular person. And not only that, you can also see that from a performance perspective. In case of RDBMS, as long as it is 2 to 3 levels, it looks okay. But a quick comparison is given here. But the moment you go to 3 or 4 levels, you'll see that there's a huge difference in performance. So while Neo4j can send or bring the 4th level within 1.3 seconds, in case of RDBMS, it would take forever. So that is, I think, the major advantage of graph database. So very quickly, a quick comparison between NoSQL and RDBMS, where we should use. So this is like more like a thumb rule. Again, everywhere we have to do on a case-to-case basis. But RDBMSs are very good if we have transactional complexity. As I mentioned earlier, if you have create a, let's say, a CRM system or a ERP system where a customer has orders and orders have order line items and so on, and you need to update them in the same way always, then RDBMS are the best. But if you need, the complexity is not so high, but on the other hand, scale, and you need to handle large volumes of data, I think that's when NoSQL databases are very good. As I mentioned, we'll talk about a few jargon. So CAP theorem is very often thrown around, which CAP stands for consistency, availability, and partition tolerance. And what this theorem says is that in a distributed computer system, at any given time or in any given system, you can guarantee only 2 of these. So that's a simple theorem. You cannot achieve all the 3. So, for example, RDBMSs are very good with availability and consistency, but when partition comes, they are not so good. And Neo4j, by the way, are also somewhat on those lines. That is one of the limitations of graph databases. Whereas if you take Cassandra, they are very good in availability and partition, but probably not in consistency, and so on. So that is CAP theorem, one of the jargons you learned. The other is acid and base. This is another thing. Many of you may be familiar with acid, but because this is RDBMS, it is used in RDBMS, which refers to having transactional consistency, if you will. So atomicity, consistency, isolation, and durability. ACID, that's the acronym. And they came up with a similar acronym for NoSQL. What it means is that it doesn't provide consistency always, but eventual consistency. So they call it basically available soft state, eventual consistency. Now, don't know who came up with these, but these are again some of the jargons. and we need to be familiar with this. Some of the myths, I think there are just a few more slides, so we'll wind up the presentation and move into Q&A. The commonly held myth is that NoSQL databases are only for read-only purpose. They should be used. Not really. They can be used for writing as well. And other is that NoSQL databases are a part of Hadoop and always used with Hadoop. No, not really. They can be used without Hadoop as well. You can write a regular Java application and use NoSQL as your storage. And that the NoSQL databases do not have schema at all. As I mentioned, they have an implicit schema. So you don't need to create the schema in the beginning, and the schema is not rigid, but at the same time, they also have a certain amount of schema. So those are some of the myths. What are some of the disadvantages? So as I mentioned, these are not a solution to all problems. So there are certain disadvantages of NoSQL databases. They cannot handle complex joins. So you need to write in your code if you have to create joins across two tables or column families or something like that. You need to take care as a programmer in the code. And there is no support for intrinsic support for complex transactions where you need to take care of consistency and all those asset properties, but you can write your code in such a way that all this is taken care. And similarly, constraint support is also not there. So what is the future? Is this the end of RDBMS? Definitely not. So what the future will be a combination. We will have applications which will have a combination of RDBMS and traditional databases and NoSQL databases. And that is known as polyglot persistence. That's another jargon. So where you use multiple databases or multiple types of databases, each for doing a certain activity, but in your overall system, you will have a combination of these databases. So that is called polyglot persistence. So quick recap. So what is NoSQL? It is not only SQL. So we still use, in some cases, as you have seen, we still use SQL commands and so on. It's not a solution for all problems. Yes, it is good for handling large volumes of data, especially unstructured data. And finally, RDBMS is definitely here to stay. They are not going anywhere. And last slide is on, as I promised, some of the jargon. So we have seen, you must have now got familiar with what is big data, Hadoop, NoSQL, asset and base properties, gap theorem, horizontal scalability, and polyglot persistence. All right, with that, we will move into the Q&A session. So,
thank you, Mohan, for the insightful presentation. Let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to the insights.
Sure. So let me check the questions here. There seem to be quite a few.
There are overwhelming number of questions we are receiving.
Yes. So we will, I think logically we'll go as first in, first out. So I'll take up the first question. This is from, I think, Swayam Rangarajan, I guess. And the question is, when we say variety, velocity, volume, just because we are creating petabytes and zettabytes of data, that is only reason to call big data? Yes, I think that is a traditional way of explaining big data. So the main reason is that the data is increasing, and the type of data is more important, which is unstructured data. And again, these are not my terms, so I'm just a messenger. This has been there, and people have defined it that way. So, okay, so those are the 3 V's. The next is from Adil Kalim. So Adil says, sorry to interrupt, Mono, you're not interrupting, but I believe there's a fourth V, also this model called veracity of data. Yes, Adil, you're very right. And in fact, there are a couple of more V's, not just a fourth V, but maybe a fifth and a sixth V. People started adding V's to that. Veracity is one. I agree, but I thought I'll keep it simple. And again, remember the idea was not a detailed discussion on big data, but just to set the context of big data. So those 3 V's were sufficient, and that's the reason I did not bring veracity, but you are very right. Veracity is also another V. There is one more question from Swayam again. Is big data concepts point in time? How do we validate data is obsolete? Yes, so I think that's a very good question. So again, the data validation and data cleansing, these issues are there and will continue to be there. So there is no one answer for this. There are multiple ways of checking data validation and cleansing of the data. So that all is a part of the overall handling of data. So that is still there. That doesn't go away. Next question is from Savita Sarvanam. Can't big data be processed with SQL? Yes, I think that's the whole idea. There are some challenges. I'm assuming when you say with SQL, you're assuming traditional databases, RDBMS. So we probably can, but it is much more difficult. So for example, can you create a cluster of MySQL or RDBMS databases? Definitely you can, but it is much more expensive because you need to create all those indices and all that everywhere. So it is not that easy. So the simple answer is, can you handle? Probably yes, but it is extremely, extremely difficult and painful and expensive. Next question is from Ajit Kumar. Ajit says, hi, does key value store based database overcome the single point of failure, or is it only RIAK? So this is primarily RIAK. Not all key value stores have the same model. So the single point failure or the lack of single point of failure is for RIAK. Rahul Gupta has a question. He says, is there unstructured or structured data only difference between big data and relational databases? That is not the only, but I think that is a big difference. As we have seen in case of big data, the unstructured data plays a very big role, and the tools provided are a lot more useful for unstructured data. So while unstructured data plays a big role, but that is not the only difference. There are other differences as well, but that is one of the significant ones. All right. So the other is from one more question from Ashish Kuryal. What is the difference between various NoSQL DBs like MongoDB, Cassandra? Which one is more Windows friendly? Okay, I think it's a very good question, and that is exactly one of the points I mentioned. So each NoSQL database has its own positives and maybe some negatives. So you cannot kind of use them interchangeably. Each of them has a certain strength, and for a specific use case, a particular NoSQL is extremely useful, whereas another one may not be. So for example, if you're creating a social media-like application, a graph database like Neo4j is the best suited, whereas MongoDB will definitely be a misfit there. So so you need to really understand the various differences and strengths of each of these NoSQL databases. So there is no straight answer for this. And I also wanted to take this opportunity to mention that it may be difficult for one person to know all these databases and everything around that. So we can only have some idea about all these, and then going into deeper into one of those NoSQL databases based on your situation, which project you're working on, and so on. Okay. I'll probably take 2 more questions. We are almost at 4 o'clock. Ashish, I think I took up that. Now, Abhay Sequeira, I hope I pronounced it right, is asking, if I were to develop a document management system, what type of database should I be using? Okay, so while this is one myth or a misnomer again. When we say document databases, it's actually not handling. I'm assuming that's the context in which Abhay you're asking. So if you're thinking that document database like MongoDB or HBase is to be used, definitely not, because here the document refers to actually the JSON object and not really a Word document or a PowerPoint. And I think what you're referring to is a document management system, like you have files and so on. So you need to again evaluate what is the best NoSQL database you need to use, or maybe even SQL database. So that is Abhay. We have one more from Adil. I'll have to skip that, Adil, since I've already taken one question from you. Let me go to Sachin Virmani. What are the parameters used, based on which you decide whether a business requirement needs a traditional DB or is a candidate for big data? Excellent question, Sachin. So that's exactly an exercise that needs to be done at the beginning, and again, there is no one answer for this. There are a variety of factors that need to be taken into. There are some guidelines, but again, every situation is unique in a way. So there are some guidelines, as I said. If it is a transactional, highly transactional application like an ERP application or a CRM application, you definitely would tend towards traditional database to start with, at least for the transactional part, and then you do the analysis, take that, dump it into NoSQL database and do the analysis perhaps. But if you are working on things like collecting data from sensors, and these are less transactional, but only thing is they keep growing in size, then it's a clear-cut case for a NoSQL database. But again, having said that, every project, every case needs to be evaluated individually, and then you need to take a call. So Aradhana, I'm assuming there are a lot more questions, but probably we don't have time. Let me know, otherwise I can take up a few more.
Actually, due to time constraint, I was about to just request you to take the unanswered questions offline, which I will for sure share with you through email.
Yeah.
So if you would like to sum up the session for today, you can do it now.
Yes, definitely. I would like to first start with an apology for the interruption, but I think I hope you got a good sense of what is NoSQL, especially for people who are new to NoSQL, and you must have also seen a quick introduction to big data. The idea was to create that spark in you into the fascinating new world of big data and NoSQL databases. And I think you can take this forward by doing some self-learning and training and so on and so forth. I would like to thank you all for your attention.
And I'm really thankful to our guest speaker for conducting this wonderful webinar today. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Mohan, for your time. Have a great evening ahead.
Thank you. Bye-bye.